I'm currently a founding engineer in autokitteh, and before that, I was an engineering manager in Datadog, and before that, in Google in various capacities. And the kind of theme that I had throughout my career is basically working in the seams between backend services, infrastructure, developer productivity, um, and basically making sure that developers are able to work as quickly as possible with the highest possible quality and the systems that are necessary in order to achieve that.
That's awesome. That's very awesome. And so your talk today is going to be about.
We're going to talk about the nightmares of spiraling deployment complexity. And I want to say something a little bit about that. Throughout this month, we're going to have talks about spooky stories in Temporal, where the theme is here are the things you should avoid doing in Temporal. Here are the things you should do better. Be careful of when you do this or that. And in contrast to that, I want this talk to talk about a regular, normal, common engineering nightmare that has nothing to do with Temporal. However, using Temporal will allow you to basically get much more and get to results that are much more easier and much more attainable than if you had to do that in basically any other way. That's one of the reasons I love Temporal so much, because it adds so many interesting building blocks that are based on actual living experience.
That is so cool. That is rad. All right. Well, why don't you go ahead and kick off the presentation? People will continue
Oh,
filtering
yes.
as you get going.
So,
Oh, and while that's happening, my name's Angie. I am Temporal's head of community, and I am doing all kinds of silly things in the community like this. But we really love these community AMA sessions because it allows us to feature our community members or questions that come up frequently from our community, try to get you established with temporal best practices, or in this case, infrastructure deployment best practices. So go ahead and take it away, Daniel.
yes, thanks. So I'm going to start with something which many of you are probably recognizing as very simple, very trivial, actually. Like, I have a repo in GitHub, I want to build it. And you can see here an example from GitHub's own website on how to configure something like that. It's a simple YAML file that contains a few lines of code. You can actually read it, like you check out the code, you set up Go, you build it, you test it, and you're done. Cool. If you want to actually deploy that repo somewhere, okay, let's do that. Again, there's a link here from GitHub to show some examples to deploy to various cloud providers. Generally speaking, you have it's not no longer like 10 lines of configuration, it's now 60. And it's also requiring about 30 lines of text just to describe that file and how to configure it and how to use it. So there's a little bit of trickery there, but I guess, okay, you do it once, you know what you're doing. That's it, we're done. Boom. Like, we can finish this talk and we got 50 minutes back and everything's happy.
Good night,
But
everybody. I'm just kidding, though. Yeah.
this is reminding me exactly of this kind of situation where you show something really, really simple and trivial, and then you say, okay, let's take it to the real world. And it's just like that. No, it is so much more complicated than that. We're going to talk about what it means to have build and deployment systems in the real world in big companies. And that is a hell of a lot more complex. So just to start with a taste of complexity, something that, again, is very familiar to a lot of people, but just that single change in initial conditions makes all the difference in the world. So instead of building a single repository, let's say we have multiple repositories in a single organization. one for the UI, one for the backend, one maybe a few for different backend services, and they all interact with some common libraries maybe. So you can no longer build a single repo and be done with it. Now you have to build multiple ones. How do you build multiple ones? It's basically what's known as a DAG, a directed acyclic graph, where you have multiple starting nodes because some of these repos can be built concurrently. They don't react with each other. Great, you don't want to build them sequentially. That would be too slow. But also, some of them are dependencies for some other repo. So you have to join some of these builds as inputs for another build at a higher level. And ultimately, you end up with some big binary based on builds from multiple repos. Sure, it's still doable, but it's more complicated than that because if you have to build for multiple operating systems or hardware architectures, you take all of that and multiply it several times. So if you thought about just making it simply like, okay, I'll build one thing after the other. No, that can take hours for a single binary. So we just can't do that. That's not productive at all. Um, Developer experience there is atrocious. And because of that, you have to start being intelligent. Now, GitHub Actions, the thing that we used before for a single repo build, it sort of still works, I think, sort of well. But imagine that you have to do what we said. We have to run a few things in parallel. How do you synchronize workflows in different repositories? It's not that simple. There are triggers that you can use, but then you find out that they actually relate to the beginning of something or progress within it, not necessarily the completion. How do you say, okay, this one workflow needs to spawn multiple ones in multiple repositories? Again, repositories don't talk with each other. How do you differentiate between the success of a build and the failure of a build, and not just the fact that it started and had some progress in it or finished? All of these things mean that if you really want to do it in a robust way, you actually have to create a system for that, unfortunately. And when I say system, it means software developers getting together in a team with a charter, calling themselves developer excellence maybe, and starting to design and implement a system. That is a huge effort. Uh, Even if you think about it as an effort of two people for 3 months, which is optimistic, but it's possible, depending on the size of the builds that you're referring to, then even that is a lot of time when you come down to the details and calculate that. Also, you have to think about all the different considerations here. Like you want to do it as fast as possible. The operation of the system, that system needs to be as fast as possible when it's building stuff. But also, you can't just waste resources infinitely. You have to throttle it. You have to be efficient about it, but also you have to make it so that it's not perceivable by the developers. Again, we need to maintain velocity. You also have to maintain provenance. Like this build depended on that build and that source code and this version. If you're thinking about designing the UI for that, the database schema for that, it becomes a nightmare in itself. And remember, we haven't even gone to a lot of stuff yet.
Right. This is still like
Um,
best case scenario, right? Like best case
yes.
scenario. Yeah. I have a quick question
Um,
for you, Daniel, if it's okay to jump in here, which is, there's some folks who like start their own startups on their own laptops and like that kind of thing. And then at some point you become Google or somebody who has like do you recall when in your career you hit the point where this type of management of infrastructure and deployments became necessary? Like to the extent that I don't want to violate NDAs, but to the extent that you could share, like at what point is this something that people should be thinking about in their
Yes.
projects?
So one of the things that I've done in Google was join a team in the very early stages of its inception, where we started as a single cohesive unit of 20 people, and we created a brand new product, and that blew up exponentially. It was not a surprise. That was the intention all along, but getting to that scaling, that scalability, not just in the product itself, but in the engineering organization, that takes a lot of planning and a lot of careful decisions, or sometimes wild decisions, in order to make sure that you're not spending time on unrealistic endeavors or things that just won't benefit you enough in the long term.
Yeah.
And
Okay.
that's exactly one of these things. Luckily for me, in that place, I had the benefit of using existing Google infrastructure to some extent. And in a way, that's actually why, again, I love Temporal. Temporal wasn't used in Google, to my knowledge, at that time at least, but having infrastructure that basically allows you to just plug in your additions to it, your code, your logic, and see it run robustly, reliably for you, that's a huge step. That is something that a lot of companies usually don't have. And that's why I see Temporal as basically democratizing that kind of technology.
Oh, thank you. That's awesome. Okay.
Sure. Um, yep. So we talked about building multiple repos. Let's talk about a very well-known paradigm of deployment. That's called blue-green deployments. For people who are not familiar with that term, it basically means that instead of having one set of infrastructure components that you update all the time whenever you want to do a release, it's basically using that famous adage, why pay for one system when you can pay twice for two systems? And you do that. You basically have two mirror environments. One of them is running the production code. You have another backup environment. You you deploy the new code and the new release on that backup environment. Then you route users to that new environment. And after you make sure that everything's okay and everything is sane and you don't need that old release anymore, you can either turn it down or focus on a new release there. Basically, it means you're switching between environments all the time to make sure that the product is always up, is always responsive with some kind of version. Now, the way I described it might seem kind of vague or unclear, or it might seem very simple. The thing I want people to take from this is that what I described is, in a way, basically a procedure. You start in some state, you deploy and install things in a specific place, you configure the router to switch to that place, you wait a few moments, an hour, a day, whatever, and then the procedure is complete. This is exactly what a workflow does. You basically say, okay, I am developing a procedure automatically that does all this. This can be a temporal workflow. That is wonderful, cool. I mean, all the little details of failures are basically abstracted away by temporal concepts. I don't really want to say abstracted because you have to understand what you're doing there, but you have to see that if, for instance, the deployment of a specific node failed, that could be an activity. If that activity fails, it can be retried. But if something more fundamental failed, then the whole workflow can fail. That is up to you. That is very easy to implement, as opposed to a system that does this. Now, to be fair, cloud providers do provide usually some kind of blue-green deployment options, but stray just a little bit off the trodden path, and you find that what you need to do is impractical and sometimes impossible unless, again, you have a system for it. So we have a system for builds. Now we're extending it to be a system of builds and deployments, or even creating another system. This is a lot of work, unless you can use Temporal to basically create two workflows, that's it. And you're done. All the configuration stuff of where it's being deployed, where it's being built, these are just input parameters for that workflow. Now, I mentioned that we can wait in deployments, like before we decide that an old deployment is no longer necessary in case we want to roll back. A common way to do that sometimes is to have manual approval steps. So you can have a person, maybe it's an ops engineer, a reliability engineer, signing off on some checklist of conditions and saying, okay, now we can go to the next step. Now we can declare this new deployment done, or now we can start that deployment because I'm confident that the code involved is correct. Actually, sometimes it's even a legal requirement in some cases, in some conditions, but let's not get there. So you have a big red button and you have to click it, you press it to do something with it. Now, if you ever had to create a system that allows for manual approval with people, you know that you have a UI for that, because God forbid if you have to allow people to do something in a non-cool UI, even if it's internal. You have to have a database to keep the state of their choices and map it to all the things that they approve and have a history for that, and people need to be able to audit it. That is a lot for such a simple system, basically. Imagine that you do that in Temporal. How would you do that in Temporal? Temporal doesn't have like a fancy UI for manual approvals, but actually it can. Like, let's say you use Slack as your medium for approvals. People can send a Slack command or approve it as in a message in some kind of channel. And all you have to do is have a Slack worker built in Temporal that receives events from your workspace and allows the code to send messages and interactive messages. So basically, that workflow that we described earlier, for instance, that does the deployment, it can start by having an activity that sends a message to a relevant channel or a relevant person saying, do you approve this? Is it okay? And that's about it. Because once they click that button or reply to that message, then the workflow gets that response as an event, as a signal, as whatever, and continues the workflow. What happens if our temporal server crashed during that time? Nothing. It will keep that knowledge. What happened if anything else crashed in the middle and got back up? Nothing. We keep that state in temporal. It lives on practically forever, or however you configure that, waiting for the people to do the right choice and knowing how to map that choice to the right destination.
That's really interesting. So just to where we're at in our plate is if we're doing all of these things, we now have what, four different systems? We have a system for managing deploys, we have a system for managing builds, we have a system for now managing manual approvals.
Yes,
And then in this other scenario where Temporal was running the workflow to begin with, this is just a bit of logic that informs it to wait until it receives a response. And
exactly.
just kind of
We're
add.
basically talking about two workflows, maybe one to do the builds, where different repos are represented by either different activities or different sub workflows. You have a second workflow for deployments, and we just added Slack as a third-party worker to that workflow, but it's still a simple single relatively easy to describe workflow in Temporal.
Yeah, wow, awesome.
Yep. And now we're getting to the really interesting stuff. So let's say that your company is really successful, so much so that it's becoming a victim of its own success. And you have to deploy your product not only on that little laptop that's hidden somewhere in a closet, but rather in a real data center. Um, People who have dealt with that for real, like DevOps engineers, they know that this is not something for the meek. Again, there's a lot of support, a lot of help, a lot of examples on how to do things, but this is where complexity really rears its ugly head. And we can see here, by the way, a map of AWS regions across the world. Azure has something similar to that. Google has something similar to that. Basically, you have multiple regions per continent. So multiple regions in the US, multiple regions in Europe, multiple regions in Asia, few more, obviously. For each region, you have multiple availability zones. Now, let's focus a little bit on availability zones first. We're not that successful yet. We're just working in, I don't know, US East. That's a common choice for many companies. But you have to deploy your code in multiple availability zones in that region, because if something, God forbid, happens to that physical data center, you want the two other data centers in its vicinity who are not affected by that, natural disaster or networking outage or whatever. You want those other backups to continue working. Also, you want to basically just do some load balancing between these two availability zones. So you always want to deploy your code concurrently to multiple availability zones. Again, cloud providers have some solutions for that, but stray but a little, and you have to do something on your own. And to clarify, what that means is if you have to deploy on your own some Kubernetes nodes to multiple availability zones in a region, and you have to manage that. You have to make sure that they happen not just concurrently, but in a very synchronous way, because you want to make sure that as much as possible, the versions are the same in the same region, sort of, because who knows, maybe there's some backward compatibility bug where the UI for the latest version changes something that breaks with the older infrastructure, and you don't want to do that. You want to make sure that this risk is averted as much as possible. By the way, we will revisit that problem more later.
It's a topical problem though, like with Milton just, hitting 2 weeks after Helene, which is, there's people having conversations about, do we need a Cat 6 for her? Like it's a real life problem that happens if you rely too much on even just like a region of the world. It can have catastrophic effects, from outside. So it's
Exactly.
very important.
The math there is astounding. Like if you're talking about, people usually don't understand the math behind it. If you're saying, oh, something happens like once in a million, that happens multiple times a day in a data center. If you're talking about a natural disaster happening once in a century, it's not really once in a century, and especially now, it's probably multiple times a year. And let's not even talk about really surprising things. Like, I don't know, a fire started somewhere in a specific floor. It just happened. Who knows? So again, you want to protect yourself as the customer of that data center from things that will most definitely happen. And you just want to make sure that you're not affected by them. That's a very fundamental rule of reliability.
Well, on that comforting note, that's
Yeah, Yes. Um, we said that availability zones have to be deployed as much as possible together. What happens with regions? So again, you're a victim of your own success. You now have customers in the US, in Europe, in Asia. Some of them have requirements relating to data residency, where you want to make sure they want to make sure that their data doesn't leave the borders of their country, for example. Then you have to deploy in multiple regions. And you can think about it initially naively, like, oh yeah, I've seen that problem before with availability zones. Cool, I just deploy everything at the same time, right? I mean,
It
it
worked
sounds
for
logical.
CrowdStrike. I don't know. Like, anyway.
I mean, Daniel, you said these are just two workflows. We don't need any more. Two workflows. That's enough. No. Um, you want to make sure sometimes that you minimize risk in another way. There's another tactic, another strategy to minimize risk, and that is do a rolling deployment where you deploy to US East first, then US West, then EU North, then EU East, blah, 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 all these things. And if one of them fails, you pause, maybe you roll back, but you don't deploy everything everywhere, because when you have an outage, when you have bad code, when you have bugs, you limit the exposure of that bug by deploying it not concurrently, but as a sequence of deployments. And that's where we get to an additional layer here. So far we talked about concurrency in deployments. Now we're getting to the point where we want to have a master workflow that controls subordinate child workflows and says, okay, we know how to do a deployment in a given region. Now we will sequence these deployments as a series of deployments. If one of them will fail, then I will fail the entire workflow for the entire world. Now, we talked about various mechanisms in Temporal that allow to do that, but I want to add one thing which is relatively new, not so much anymore maybe, but the saga pattern is really appropriate here, for example, where you're not talking about just aborting a workflow when it errors out. You also have the mitigations that undo those deployments and return the system to the last sane state. You can do that in various ways, but the saga pattern, I believe, is really a nice way to deal with that from a design perspective. And so far, I want to contrast what we've talked about relating to temporal workflows. What do we have, like 3 workflows now? In the real world, where companies have the money to invest in internal development without temporal, which I've seen, they would have a system for each of these things. They would have a system for rolling deployments, because what happens there is you really need to see the progression. You need to see, okay, this deployment was followed by that deployment. If that broke, then I can now see where the other deployments are stopped and the old ones are the latest again. Temporal shows you that for free, basically. It just shows you a history of workflows. There's nothing simpler than that. We also didn't mention another general problem, unrelated to deployment specifically, but in general, when you have multiple systems, what is the most natural thing to do? Can you guess?
You probably have to aggregate the logs somewhere so that you can find out what the heck is going on.
For sure, yes. And navigating that is terrible. So what do? You create another system to manage all of the systems.
Right.
Fundamental law of engineering.
Mhm. A system for
Uh,
the systems. So to recap, this system now is the system that when we've already got Slack talking to say AWS region code, we got GitHub Action, we got all these kinds of things happening. This system is the system that tries to pull together all of the places that it could possibly have failed somewhere and make sense of it. Is that what this system is trying to do?
yeah.
That sounds like a nightmare of its own.
It is. I will tell you, again, I mentioned companies that are able to afford this type of development of internal systems spend absurd amounts of money and time on it. Because it is necessary, to be honest. Like, if you don't have infrastructure that allows you to develop it quickly, and usually you don't, the amount of time it takes to develop these systems when they're usually considered as something less important than the real product, the customer-facing product, that's one uphill battle. Over time, you have to maintain these systems and to redesign them based on what you've learned so far. That's yet another complexity there. So, yes, the amount of time and money being poured into all of this internal system, this developer excellence, DevOps, infrastructure kind of thing is amazing. It is something entirely non-trivial in a company's bottom line.
Well said.
So I think one of the interesting concepts that people are not familiar with as junior engineers is canaries. So I wanted to add that topic here. Is something that you will see in many companies. You'll also many times see it implemented badly.
Mhm.
Okay, that's the reality of life. But I want to talk a little bit about what canaries are, how they relate to deployments, how they're actually being implemented, and how that relates to temporal. If people are not familiar with the term itself, a canary, this is basically something based on a different thing than a canary in a coal mine. That's the meaning of this graphic. It's basically a practice that apparently coal miners had in the past, or I think in the past. I don't know if it's done today. I think they have better technology, where if there was a risk of people being suffocated, they literally had a canary in a cage, and a canary, being a small little bird, would suffer from these consequences first. So when you saw that the canary is in distress, you knew that it's time to leave the mine. As a metaphor in software engineering, we use canaries as a term that means basically that we're deploying something in a limited way, like a test. Not really a test, but testing in production, which is a fun conversation in itself. And we want to see what's happening with that. Is it good? Is it bad? Is it incompatible with the previous version? So we'll have to have a more careful deployment. Does it have extra errors that we didn't used to have? Does it show some issue to users that is unexpected? Or on the other hand, maybe it has some really cool feature that people were waiting for and they're happy to experiment with once they see it. And so in order to implement canaries, usually, and that's something that doesn't really have a good system for that, that I'm familiar with, you always develop that internally in-house because you need to manage that kind of experimentation. It's not just the building blocks of I'll deploy X, Y, Z, but rather I'll deploy them, but also I need to monitor them, and also I need to understand what's happening with them. This also applies to a similar term called A/B testing, if people are familiar with it, where you deploy two versions of the same thing. For instance, two versions of a UI that on the backend, they use the same backend, but they look a little different. And you measure the engagement with these UIs, which is getting more engagement, which is getting better feedback. and you choose that one instead of the other. That's also a type of canary. And how do you do that? Why do you have to manage it in a special way compared to other types of deployments? Because you usually need to define the terms of these experiments in a very detailed way. Like, I want exactly this percentage of users to be exposed to this version. Maybe I want a specific group of users to be exposed. Maybe I want some random users to get like a random sampling. And you have to be very careful about that percentage because, again, you want to minimize the risk. You start with a very simple, small percentage, maybe, I don't know, 5%, 1% of users seeing the new version. That routing in itself requires some logic. How do you make sure that only 1% get to view that new version and all the others are still using the old version? That's something that you have to create a system for. Sometimes it's called an experimentation framework, where you define experiment variables and you go at it like a lab experiment, really. And you actually see what are the results. And if that works, how does that work? How do you actually do these measurements? You can use a monitoring system, for instance, Datadog, and you look at metrics that you defined, you measure the values relating to them, you see it in a dashboard maybe. That's the usual way it happens. And someone says, oh, I like these results, let's go with it. Or I don't like these results, it looks fishy, it looks suspicious, let's roll back. All of this is very manual. And if you manage to automate it, you need another system. Yet another system. As if we didn't have enough.
Yeah.
But I hit something there. I mentioned that we're using some monitoring system like Datadog or Prometheus or something like that. How do you communicate between these things? Like, these metric management systems ingest data and they expose it in some ways, but if you have your own custom systems, obviously you need them to implement the API to talk with these systems. And that's yet another layer of complexity there. So how does that relate to temporal, actually? In a very similar way, but slightly different. I don't think that it's easy to say that it's fair to say that a single workflow or a couple of workflows can encompass the complexity of canaries, but you definitely can use those building blocks from temporal to say, I want to have a very gradual change in percentages. If step 1 failed, undo it. If step 2 failed, undo step 2 and 1. Step 3 failed, undo all the 3 of them. Again, that's a repeat of the saga pattern, in my opinion, but also there are other ways to do that. And you can see that, let's say that you want to talk with your metrics provider, then yeah, you can have a program that does it, that uses their API, or you can have that API in a worker in temporal, and then it basically becomes just a retriable activity in your workflows. So cool, we have some workflows and some activities relating to managing experiments, managing canary builds, managing deployments with percentages that are changing over time. Does that mean, is that significantly better than having a system that does these things? What's the difference between a system that I wrote on my own or a team wrote and doing it in temporal? The difference is that these workflows can be superimposed on top of our other workflows. So now you basically have a composition of logic rather than interconnection. Composition is always, or almost always, easier and safer than connecting systems together. And I think that's the last.
Just on your last point about composition as well, it seems like that also makes it a lot easier. Like, let's say because all of your talk was about the green field path, like the everything went well kind of thing. And if something does go wrong, you are one of today's lucky winners. Um, it seems like the more decomposed that your workflows are and the more specific they are, that this one does that and this one does that, the easier it's going to be to figure out where the problem is and fix it. Is that accurate to say?
Oh yes, for sure. And something very nice here is that there's a concept of black boxing. So for sure, if I'm a part of a team that maintains this set of workers that are all doing the same thing together as a single body in some kind of worker or multiple workers, that's great. But also I can assign responsibility to specific developers and say, this developer is in charge of the workflow that handles just the blue-green deployments. And that developer is in charge of the rolling deployments. And while I expect them to talk with each other and know what each of them is doing, they don't need to actually synchronize anything between them as long as the contracts are clear between their workers. When a worker calls a different worker with a specified input, expecting a specified output, that's basically it. They don't care how all the nitty-gritty is implemented under the hood. And that's wonderful.
The dream, right? Developers don't have to talk to each other. I'm just kidding. No, that's
No, no, no.
that's just chaos on its own.
That's
Anyway,
not the takeaway of that.
no, I'm kidding. Daniel, thank you so much. That was amazing.
Thank you.
Yeah, lots of great insights. If you want to flip to the next slide, just to give a quick shout out, there are in addition to Daniel's awesome talk, last week we had Josh talking about temporal anti-patterns. We've still got two more kind of live Q&A sessions like this, one with our co-founder and CTO Maxime at the end of the month, and then hopefully with hurricanes abating, we really hope then Tio will be able to give you a recap of his replay talk of terrifying tales from the temporal trenches, where he talks about how to think through a problem that occurs. So, and then all we have left now is just Q&A. And I know the Q&A box has been a little bit quiet. However, I've been getting some questions on other channels. So why don't if you want to kill your slides, and we can just chit chat for a little bit here. One of the questions that came up in response to this was, infrastructure management. Sorry, I don't want to say infrastructure management. You corrected me on that already before. Infrastructure management is this whole thing. You're talking about deployment management specifically.
Yeah.
So, but deployment management is one use case for temporal. Infrastructure management as a general concept is another use case, kind of around this whole DevOpsy kind of area. That's a lot of times how organizations get started with temporal, even is the engineering team that's in charge of all the things brings it in because if something goes wrong, nerds that know how to fix it find out about it before customers do, for example. And that's usually kind of like patient zero, and then it kind of takes off from there. But a question that we got from somebody is, I've heard of temporal, and I never really understood what you would use it for. And I know you have been using temporal for a while, and I'm just curious, like, what are some use cases that you have either seen done with temporal, or that because you also have a product built on temporal, is that correct? And I'm just curious, like, what are some of the more interesting use cases that you've seen in your experience?
So I'll do a little bit of plug of what I'm doing in autokitteh, which is based on temporal. What we're trying to do is basically allow users to write their own simple code that has absolutely no consideration to what we've talked about. You don't have to know about complexity. You don't have to know about temporal. You don't have to know about reliability, retries. All you have to think about is, I write my code with my logic. It does X, Y, Z, and that's it. And AutoKitty tries to take that, well, it succeeds in taking that and adding all that reliability, all that complexity of managing credentials, managing state, using temporal, and does that automatically for you. So it's basically not just solving the problem of writing code to manage complex workflows. It's also avoiding the complexity of the workflow management in Temporal. But to answer another layer of that question, the kind of use cases that I've seen where companies use Temporal, it starts, at least where I've seen it from the ground up, basically like grassroots movements with developers saying, I know I don't want to create my own workflow management system. I know I don't want to create my own framework to manage OAuth and databases and web deployments and all that. So I'm just going to use that cool tool called Temporal, which allows me to just focus on writing a little bit of code. And you can see that a lot in DevOps scenarios where DevOps engineers have a lot of work with various frameworks and tools and platforms that notoriously are unfriendly and not willing to play nicely with other platforms. Like, I love Kubernetes. I adore Kubernetes, but I will never say that Kubernetes is easy. And if you want to manage a product using Kubernetes professionally, you can use Kubernetes operators and lots of other things, Terraform, a lot. But somehow, at some point, you have to manage that automatically. You can't just rely on operations doing these things manually, because then you get to a point of bus factors. What if the relevant person who knew exactly how to do it is asleep or sick or on vacation? There are human limits to what can you do, to what you can do without automation. Automation just takes away that complexity completely. It solves the problem of, well, I need a person with experience to do that, because you no longer have that. That experience is in the code. The code is the experience, and you just see it running. You just trigger it. And in many other cases, I've seen also engineering teams seeing that marvel in DevOps and saying, well, we want that too. Like, we have our own internal system to deploy services in production, but I don't want to actually manage that. I don't want to like go into some node or go to the Fargate UI or whatever and manage it. I want something to do it for me. That's yet another very common place for Temporal to be used. And I'm not even talking about the extremely common scenario where Temporal's data sanity is important, where you make sure that data isn't lost. And that's relevant in financial systems, in systems that support or provide auditing capabilities, where accuracy is super important. Developing a reliable system that maintains state no matter what is extremely difficult, and people who know better usually try to avoid it.
Well said. Well said. Awesome. What are you like? You just came from Replay. You've been using Temporal long enough that you built a product. What are you the most excited about, kind of in the Temporal ecosystem, or in something big takeaway you got from Replay, anything like that?
Say that the thing that wasn't really surprising, but very pleasant to see that it really is an ecosystem. So I've been in the last two Replay conventions, and you can really see the change there. You can see that it's not just developers scoping out what this thing is, trying to learn about it. Do they want to add it to their organization? You also have a whole ecosystem of service providers, of people who know how to use Temporal and are ready and willing and able to help companies integrate it into their systems. And that's amazing. Also, Temporal itself is focusing on something relatively new-ish called Nexus, which also supports that way of thinking, which is let's provide functionality as a service. People can just use it through Temporal instead of having to repeat the exact same thing. I mentioned earlier Slack workers, Datadog workers, things that interact with third-party systems. Mostly, even companies that use Temporal will have to create their own internal workers to do that. And while that may not be too terrible to do that compared to doing it in your own service, it's still time consuming. And there's no need to do that if someone is already giving you that, which, by the way, AutoKitty does.
Ding. Yeah. No, that's very true. Like, yeah, I was struck by that too, that there's a lot of people solving a lot of the same types of problems. And I think Nexus will help a lot with like, hey, we already went down the road and got the black eye and whatever to show for it. And here's how you do Slack or whatever. And then other people can take that and run with it. I think that's going to be
Totally.
very. I have one last question for you, which is, I feel like in a lot of ways, Temporal is kind of like the software world's best secret because it like makes you like this amazing developer who can focus on business problems, and like a lot of this toil that you've been talking about is sort of handled for you, or at least allows you to decompose problems into the point where like you can fit it in your head and it's not this sprawling massive system. But I feel like hardly anybody knows about it. How did you yourself first learn about Temporal? Do you remember?
Oh, yeah. So the first time I was acquainted with Temporal was when I joined Datadog.
Hmm.
I joined from Google. Google is famous for doing things internally and usually not outsourcing, open sourcing their stuff. By the way, they've changed that dramatically. But to the point, they like all of the infrastructure related to developer excellence, DevOps is something that was developed and maintained internally in Google. As opposed to that, when you come to the real world, so to speak, you see that companies who cannot afford that huge investment are looking to existing off-the-shelf products like Temporal, like many other things. And the quality, honestly, is comparable.
Hmm.
It is definitely in some ways, Temporal is better than things that I've used in Google. And Datadog, for instance, committed really heavily to using Temporal. And that was great seeing that. That's how I learned about it. I became familiar with it because I was also working in an infrastructure team which was trying to find better use of Temporal in their day-to-day work.
Interesting. So you've kind of seen it from both sides. You've seen it from the side of we're investing in these systems, both people and technology, to make these really hard deployment problems possible. And then you've also seen it from the side, it's like, we ain't got time for that. What can we just buy or like, set up real quick?
Exactly.
And you said like, and your takeaway is that the quality between the two is comparable, but obviously one is a lot cheaper, both in terms of person power and actual finance. Wow, that's really cool. That's amazing.
Mhm.
Yeah.
Yeah.
All right. Well, we're gonna definitely have you back on one of these. This was amazing. Hey, Daniel, thank you so much for all of your talk. I don't know if we want to sign off with our stupid things or not, but anyway, I just really appreciate you being here, sharing all of your hard lessons learned. I think that was a fantastic primer on deployment in general. Just you covered all of the basics, and then it's great to hear that Temporal is helping you with these problems and other problems too. So thank you so much.
Thank you.
Okay. Thanks so much. All right. Thanks, everybody. We'll get the recording sent out and the accompanying blog post. Okay. You're the best, Daniel. Thank you so much. Okay. Bye-bye.